Hi guys. To continue with the lesson, we are going to look at the compound angle formulas. We're going to apply them to solve a problem to find its exact value. Whereas yesterday we were just taking known decimal values and putting things in terms of other fractions to reveal properties. This time we are going to look at some angles that we could potentially express as a sum of sine A and B, and expressed as a sum or difference of A and B being the standard known angles. So these standard known angles that we know of are the pi over 2, pi over 4, pi over 3, pi over 6 guys. They're our old friends, and we know them so well because thanks to the unit circle, their exact values are very easy to find. So let's use our special angles. So we could use pi, we can use pi over 2, we can use pi over 3, we can use pi over 4, we can use pi over 6, and any sum or difference of those guys ideally will reveal properties that we can use. So let's try and find the exact trig ratio for sine of pi over 12. Well, first things first, sine of 1 pi over 12 is the same thing as the sine of 4 pi over 12 minus 3 pi over 12. I chose those numbers carefully because they reduce nicely to the sine of pi over 3 minus the pi over 4. Well, luckily enough, we have an identity for the sine of a difference of two angles. It is right over there. And we are going to apply it now. So A in this case is pi over 3, B in this case is pi over 4. So this is the same thing as the sine of pi over 3 times the cos of pi over 4 minus the cos of pi over 3 times the sine of pi over 4. As to where these formulas all came from, feel free to watch the other video that I posted in this classroom post that talks about their derivation. I'm not going to go into it here. Some things to note about these compound angle formulas is that the sine ones result in sine cos sine cos. Well, sine cos cos sine cos cos sine, and they have the same signs. So they have the same signs, and you can see that it's like sine bread for a cos sandwich, sine bread for a cos sandwich. So that's actually how we're going to write it down. We're going to say it's a cos sandwich. It's not the most delicious sandwich I've ever eaten, but it's pretty good. The cos ones you'll see is cos cos sine sine, cos cos sine sine, but they have opposite signs. Plus becomes minus, minus becomes plus. So there's some tricks for you. Opposite signs, and this is cos cos sine sine. So start with cos. Okay, so now we just have to evaluate each of these individually and then work it out. So the sine of pi over 3, you can use your special triangles, you can use the unit circle, you can use the fact that you have a beautiful brain and have memorized everything. The sine of pi over 3 is root 3 over 2. The cos of pi over 4 is root 2 over 2, minus the cos of pi over 3, which is a half. And the sine of pi over 4 is root 2 over 2. So there's all of our exact values. Multiply them together, do the subtraction, and Bob's your uncle, Fanny's your aunt. So root 3 times root 2 is root 6. 2 times 2 is 4. Subtract root 2 over 4. And this is root 6 minus root 2 all over 4. And that's about as close as we are going to get to an answer. I guess we could factor out the root 2 if you wanted to. We can write it as root 2 times root 3 minus 1 all over 4. It doesn't really do anything to make it prettier, so it's acceptable to just leave it as is. And if you punch it into your calculator, you'll find that both this exact value version and just blindly plugging in the sine of pi over 2 will both get you about 0.2588. That's not so bad. Okay, so we should try to practice our skills in expressing like our regular angles or non-special angles as a sum or difference of the special angles that we actually know. So you could convert to degrees, and then you could try and do them using 45, 60s, 30s. If you want to use pi, that's 180. That's one way of doing it. It's not the best, but it'll work, and that actually eliminates the trouble of having to deal with these denominators, because things get weird when you're trying to put it in terms of pi over 3 and pi over 4 and pi over 2, but you've got a denominator of 12, and you have to think, okay, what denominators might put together to make that? Some people actually find the denominators as a helpful guide, others not so much. So we could say that 7 pi over 12 is the same thing as 105 degrees. Use your multiply by 180 over pi and reduce the fraction in order to find that. And 105 degrees we can actually easily express as the sum of 60 degrees plus 45 degrees. And that gets us to the conclusion that 7 pi over 12 is, well, 60 is pi over 3, and 45 is pi over 4. Okay, let's do it again with 5 pi over 12, and that is going to be converted to 75 degrees. And 75 degrees, well, that one's not so bad either. Whenever we have a 5 at the end, that actually is kind of telling that we have to have a 45-degree angle in there. So what can we do with 45-degree angle? Well, if I take 45 degrees off 75, I'm left with 30. So it's nice that that worked out for me. So 5 pi over 12, converting back into radians, because radians are the best and degrees are the worst. 45 degrees is pi over 4, and 30 degrees is pi over 6. Finally, 11 pi over 12. Well, we can write this one as an angle measure, I suppose. 11 pi over 12. There's actually a lot of different ways of doing this. This is only one way. That's 165 degrees. And again, we've got a 5 at the end. So that's again telling that we've got a 45-degree angle in there. And so we got 45 degrees plus 120 degrees. And 120 degrees, you could look at your unit circle and just convert it back into radians, or we can realize that it's twice 60. So 2 times 60 degrees. And then converting this back into radians, 11 pi over 12 is equal to pi over 4 plus 2 times 60 degrees is pi over 3, which is pi over 4 plus 2 pi over 3. And again, that's just one particular method for breaking that down. We could also do 11 pi over 12. We could actually say this is pi minus pi over 12. And as we discovered in the previous example, pi over 12 is pi over 3 minus pi over 4. Then we got 3 angles, and then it gets kind of ugly, so I'm not going to bother with all that stuff. But pi minus one of those angles might simplify to a special angle as well. So there's like lots and lots and lots of different ways that we can actually break these guys down. In general, once we have it in this form, we can move forward pretty easily. So let's test these. And when we got to test it, show that. We just got to show that the left side is equal to the right side. So our left side is going to be equal to the cos of a minus b. And a is pi over 3, b is pi over 6. So let's do that. Cos of pi over 3 minus pi over 6. We can use some properties that pi over 3 is... You know what? Actually, this video is about to run out of time, so I will continue this in my next one.